Hello and welcome to our recording on Sphero bots. I'm Chris Beckwith, an MLTI ambassador, and I am also the technology integrator at Reedsbrook Middle School in Hampton. And I'm very excited to share some ideas on how you can use these exciting robots in your curriculum. So this link will give you access to all of the resources that I have in this deck. It's a short slideshow because we'll be doing a lot of discussing and demo videos with the robots themselves. Difficult to do this remotely and over video without you having a chance to play with the robots, but we'll do the best we can. So that link will give you access to this slideshow and its resources. The only app that you absolutely need to make these robots work is the Sphero Edu app, which looks like these first two links here. And that is used to control the Sphero Bolt. So I want to make sure that we understand when we're talking terminology here, Sphero is the company that makes several different types of robots. They make the Bolt and they make the Indy cars. Those are the two that we'll be discussing today. They have several others, but we'll be discussing the Bolt and the Indy. A lot of people use the term Sphero to talk about when they're referring to just the Bolt because it is shaped like a sphere, but Sphero is just a company and they make several different robots. So we will be talking about the Bolt and the Indy. You use the Sphero Edu app to program the Bolt. So this link will take you to where you can download that, and it is available for whatever device you may be using, an iPad, a Chromebook, a MacBook, or a Windows computer. If you have a problem downloading it to your laptop, then to your device, then you can use this second link here, which takes you to the web-based version. It is perhaps not as compatible with all bots as the first one is. It should work, but I've had better luck with the first one. If you're able to, I would recommend downloading and installing the app itself. The third link here is an optional link that will unlock some additional features with the indies, and I'll be discussing that in just a moment. So this is not something you would use with the bolts at all, only for the Indy cars if you wanted to use their advanced features. So we will start with the Indy car. I want to give you a video demonstration first because I don't have any with me at the moment and difficult to pan the camera as we're scrambling around on the floor following cars. So I'll show you a quick video and then we'll come back and discuss some of the highlights. The bots come with all the resources you need, instructions. They are controlled by these color tiles. Excellent problem solving, basic skills, measuring distances and angles, sequences. What you may have noticed there is that the Indy sells itself as an elementary device. You saw mostly younger kids in that video, and when you see these in use, you can understand why they would have that appeal. As a middle school educator, I would tell you that I have not met anyone yet who doesn't enjoy using these. Middle school students, high school students, adults, the Indy car is fun to use. It is not just an elementary device, although it may be most appropriate for that age level. I will discuss some advanced applications where you could use this in upper middle school and even senior level high school classes. It has simple linear motion, and that is what makes it good for the younger grades and good for some specific science and math applications as well. Means it when you put it down, there's screenless programming, so they do not need a device at all, no tablet, nothing. They're just using these color tiles that come with the kits. Put the tiles down on the floor at each color, instructs the Indy to do something specific, either move a certain way or turn a certain way, give a specific sound or light up with a certain color. So it's all you're programming the car with these color tiles. And in doing that, uh, for elementary students, there's a lot of applications you could do here with any classroom, no matter what your content. Sometimes teachers will put things down on the floor to act as targets for the Indy cars. So if you're learning about, if you have some different pictures of settings in the story that they're reading in class, you can put those down on the floor, and the kids could use the color tiles to program Indy to visit the settings in the order that they were in the story, or visit a specific setting, and then, well, it stops there. The kids can talk about what they know about that setting. It could be images of things that they're learning in science class, or events from a timeline in history, where that Indy visits these locations on the floor, and that gives the students a chance to demonstrate their learning. But they have the problem solving of making it get there and go in the sequence that they want. For more advanced applications, because this is, like I said, simple linear motion. If you had 8th grade physical science classes, for example, or high school physics classes, if you measure out a distance on the floor and let the bolt go and you program it to move that distance, they can time that run and use an equation to calculate the speed of the vehicle. Some of the tiles will make it accelerate. So after it is going constant speed from the first tile, if it hits a tile that makes it go even faster, they can measure out a new distance, time that, and calculate a new speed. Now they've got two speeds. They have an initial speed and a final speed. And assuming that it took a fraction of a second to do that, they could calculate the acceleration of the vehicle. Or for the tiles that slow it down, they could calculate the deceleration of the vehicle. So these are all things that elementary students it would be over their heads, but more advanced science classes, 8th grade physical science and high school physics, this could really be a valuable tool. If you were studying Newton's laws of motion, we have a lot of applications there, whether it's 8th grade or high school, because if we wanted to look at how mass affects the acceleration of the vehicle, with the force being constant, the force is provided by the motor. They could increase the mass of the vehicle by stacking some additional mass on top of it in the form of coins or something that you could tape to the vehicle, and see if there's a difference in how much time it takes to get up to its full speed when there was no extra mass on it. They could measure those masses, and they could do some calculations with those using Newton's second law of motion as well. So I said it's screenless programming. However, if you want to unlock some advanced features, you can use that app that I showed on the previous slide, and that will let you assign additional colors to the Indy lineup. So you could print off these color tiles and have these new colors, and then you program these new colors to do different things. Turn in a different way, change its speed in a different way, play a specific musical note, or change a different color. So being able to do that unlocks a realm of new possibilities as well, because if you know that the bolt can play a specific musical note when it hits a certain color tile, then kids could figure out the timing and the distance and the spacing to get the IndyCar to hit the different tiles, play a certain musical note at a certain time, and actually program it to play a song as it goes on its route. That would be a really challenging activity, but it's possible with the extra features in this app. Something to keep in mind is that when you do reprogram it, all of a sudden the bolt is not behaving the way it is. Someone might reprogram it so that the original color tiles no longer do what they did by default. So the next group to come along and get the IndyCar, if they if it hasn't been reset, it's not going to behave the way they expect it to, and that can be confusing and frustrating. So we just need to make sure that after it has been reprogrammed with the app, you reset it either using the app or by just holding in the power button on the back of the Indy, and that will, for 3 seconds, and that will reset it to its factory default. This is great for problem solving. I give the kits to students, to adults even, and say, I'm not going to tell you anything about these. I want you to figure out what they do. What does each tile do? Take some notes. What does it do for the speed? What does it do for the angle? What angle is that? What would you predict the angle is? Then what colors do you notice? What sounds do you notice? And have them just be observing everything they can. Once they figure out what everything does, then give them additional challenges. One great challenge is to see if they can get the IndyCar to go in one continuous loop once it starts without using any tiles from other people's kits, because there are some tiles that make it turn at a right angle, but there aren't 4 of them. So they would need some other way to get it to go in a continuous loop. So I also said it would be most appropriate for younger grades, K through 5, but given the advanced applications we were talking about, calculating with science and math, uh, using formulas, definitely some applications here for older grades as well. Tile management. Imagine all of these rubber tiles, color tiles, scattered all over the floor. Each group has their own stack of tiles, and they're all scattered around. One group's next to another. At the end of class, someone might grab someone else's tile, and it gets put in their kit. I don't know if you noticed at the beginning of that video, there was a in the booklet and in the cases that contain the tiles, there's a little color chart, and it shows how many of each tile there should be. So allow some time at the end of class for tile management. Make sure that everybody counts their tiles, make sure they have the right number of each tile, of each color in each kit, and verify that before they pass it in, because the next group gets them and they don't have all the tiles they need, and that can be very frustrating. Clean up. The rubber tiles themselves tend to be hair magnets. So if you're not using these on a carpeted floor and you're just out on a tile floor, give it a sweep first. If you can borrow a big broom, sweep up the area first. It'll make a big difference in getting tiles back that don't look like that you just picked them up off the hair salon floor. And same thing, you don't want these hairs getting wound up in the wheels of the IndyCar itself. That can be a pain. Speaking of which, as a hazard, they do stop running after a period of time, but the wheels will turn on their own. Once it started to move, it does take a few seconds for them to stop unless it comes in contact with the color that stops it. So while those wheels are turning, you want to warn your students, make sure that you don't accidentally put that up to your hair, because you will wind your hair up in those rubber wheels, and good luck getting that out without scissors. Seen it personally. So hopefully you have some ideas here on how you could use these fun vehicles with your students across the content area and across grades. The Bolt is a much more advanced device, and I'd like to show you a video of that, and then we'll discuss some of the highlights. So the Bolt, if you see it there, is basically a little robotic hamster in a ball. It's a drivable robot, but it's trapped in a sphere. It's a waterproof sphere, which unlocks some additional potential there. It's loaded with sensors and can be programmed in a multitude of ways. So compared to the Indy, the Bolt is highly maneuverable. It can turn, it can travel in an arc, it can go forwards and backwards. It is extremely maneuverable. It has a lot of sensors on it, in addition to the gyroscope, which helps it keep itself upright all the time. So that LED matrix you see there is always on top. It has a light sensor you could use for a lot of cool experiments. It has a motion sensor to know if it's been kind of its altitude, sort of. It knows if it's been picked up. It knows if it's falling. Because of the gyroscope, it knows the angle at which it's being tilted. So a lot of interesting sensors there, which when you're running the program can provide real-time sensor data in the form of line graphs. So while a program is running, you can look at graphs of position versus time, or distance versus time, or its rotational axis, or all these different graphs for analysis, which could be really cool. Speaking of graphs, what I didn't mention with the Indy, for some of your advanced classes, while the Indy is driving across the floor, you could put down a little marker for each second. Someone could call off the time, and you could put down a marker for each second, and time it, where how many seconds to get to the first marker, how many seconds to get to the second. And with that data, kids could plot a distance versus time graph and see what that looks like for one speed, and then see what it looks like after it has gone over the tile that makes it increase its speed, and after it goes over the tile that makes it decelerate, and compare these distance versus time graphs at different speeds to see what they discover. The Bolt will give you graphs like this in real time, and so you could still do it manually and compare to the graphs that it gives you, but students can analyze this data instantly as soon as they've programmed a run. There are LEDs all over this device. You've got the main LEDs on the body. You can see some of them here, so you can control the overall lighting of it. But you also have this really exciting grid on top, this LED matrix, they call it, which each one of those LEDs can be one of many different colors, and you could have lessons and activities where all they do is program this grid and get some education out of that. Programming the Bolt can happen in the form of blocks or JavaScript. So this is a great opportunity if a lot of elementary kids are familiar with using block coding because they've done this with using Scratch or similar programs. So if they know how to snap those little puzzle pieces onto each other, then they can program in with the block coding. And I'll show you an example of that in the program in the Sphero EDU app. I like to use the JavaScript programming. By the time they're in 8th grade, I like to challenge students to kind of take that next step away from block coding and towards actual text coding like they do in the real world. So we have a reference that we use. You don't have to be an expert on JavaScript. I certainly am not. There's a reference that you can use there. So the kids say, well, what's the code to make it move forward? And here's the code. They type that code, they put in their parameters, and then they're doing it. They're actually programming a robot using text coding, which is really exciting and a great next step. It can also be controlled by just drawing on the trackpad, which the kids love, but there's no learning there. I really only allow them to do that and by using keys on the keyboard, they can drive it directly. So there may be some applications for that if you set up a specific obstacle course and you're trying to get your robot to different events, but there's really no learning as far as programming when it comes to that. So I discourage that unless they've written a program and their bot is on the other side of the room and they're too lazy to get up and go get it. I let them drive it back to their lab. So in this video, we see a silicone shell around the Bolt. All the kits come with these silicone shells. It's designed to give it better traction on hard floors where it might slip because it's a hard plastic shell that might slip against a hard floor. So these rubbery silicone shells are great for that extra traction. The outside of the shell has a texture on it, kind of like a little tire tread. The inside is smooth, so it's easy to get these flipped inside out. Make sure the smooth side is inward on the bolt, and the outside is the textured side. Like the rubber tiles used with the Indy cars, these silicone shells are hair magnets. And so you can imagine with the bolt rolling all over the floor and especially into the nooks and crannies of your room, under chairs and desks where nobody ever goes or looks and maybe even brooms don't reach, that these are going to find enormous clumps of dust and hair and things that you wish you had never seen. So do your work ahead of time, clean up your floor area. You can, some people use pool noodles, put them down to kind of block off areas where they don't want these to go that might be hard for kids to fish them out afterwards. I have the students keep those shells on at all times because even if they would be using it on a carpet surface, because it protects that clear plastic shell otherwise. The once that clear plastic hard shell gets scratched up, which it will just by rolling around on a hard floor, then it becomes fogged up and you can no longer, it's much less attractive. You can't see the electronic components inside, especially the LED matrix. It would obscure your view of that. But most importantly, it would make it difficult to read the name on the bolt. Each bolt on the underside of it, it has a printed name. And when we go in the app, I'll show you that in a moment. It's easier if you can see the name to pair it up. With the newer models, the name is very easy to read, and that's a simple process. With the older models, the name is printed in small, dark letters against a dark background, and it's just about impossible to imagine a way that they could have made that more difficult to read. So I'll explain a different method for pairing them up, but my point is if these shells get scratched up, if the clear plastic sphere gets scratched up, it's going to be difficult to read the name of the bolt. It's going to be difficult to see the LED matrix. Definitely worthwhile to keep those shells on. Some days when I'm having the students just program the LED matrix, I will have them put it in the shell on their desk and then peel the shell open a little bit. You saw how it was always kind of open there at the top. I would have them peel that back and use the silicone shell as a kind of a little nest for the sphere to sit in. And that keeps it from rolling off their desk while they program the matrix. So they get a nice clear view of the matrix, but it's also safe from rolling onto the floor by sitting in that shell, which is now kind of folded back and no longer rounded. And that's the other thing I remind the kids, never start these up when you're going to be using a movement command. It better be on the floor because we don't want to start it moving while it's up on their table, because they are pretty rugged, but we don't want to test that. Once they're cracked open, that's the end of the bolt. And these I've got there that they are maybe most appropriate for middle school up through high school because of the advanced features, but there are certainly things that kids can do in the lower grades. They can do what they call the drawing method of controlling them, where they just draw on their iPads and it'll do a pattern on the floor. They could do simple block commands to make these. That lower elementary kids definitely could use the block commands to make these visit different locations around their room and program pictures on the LED matrix as well. Before I show you the Sphero EDU app, I'm going to talk about pairing in there. We talked about protecting them and the cleanup as well. So let's go look at the app. If you have any issues downloading the app, sometimes your IT department needs to assist with that. All right. So Sphero EDU app, we open that up. So we'll say create program. You can name your program here. It's better than having a whole library of untitles. Drawing is the simplest method of controlling it. Really no learning involved with that, but the youngest kids can can handle that much at least. The block programming is probably where you'll start, and the text programming using JavaScript for the more advanced students and when you're ready to take that next step. So we're going to choose block coding, then you choose your robot below. So I'm going to say Sphero Bolt, and then we are going to say create. And you've got your blank canvas here. The first thing you would need to do is go up here to connect your bolt. When you click that, we say we want to look for Sphero Bolt, and it's looking for them. If I had my case of bolts here, we would see all of the bolts that are within range. It uses Bluetooth to identify the bolt, so you would see all of the bolts that are within range. They would be showing up on there, and it shows their signal strength. So if you have one on your desk versus across the room in the case, it's probably going to have the stronger signal. I mentioned that if you can see the name on your bolt, if it's easy to read, you can just read that name. It'll say SB for Sphero Bolt and then a number or letter sequence. Then you can find that on the list. Then you can pair up with it. If you can't read the name, when they're in the shells, you can't read them. You have to peel the shell off. You have to look. And if it's the harder to read, it can be difficult. So sometimes I will tell the kids, don't take one from the case. Leave them in the case and just connect to a random one. Once they've connected to it, they can go into the controls for the bot where they can change the color. And I say, pick a unique color for your bolt. Then when they go to the case and there's all those bolts sitting there in the case next to each other, they pick the one that's their color. And it's a fun method. It takes a little bit longer, but it's a fun method of choosing the bolts. So I can't get a bolt right now, so that's fine. We're not going to do that. First thing we can experiment with is the matrix. This is something you could do classes on completely alone, but when you think about the ability of this robot to not only travel around and visit locations in your room, but also to display something on the screen, either writing or an image, there really isn't anything you can't imagine, any content area where this couldn't be used. The categories across the bottom, if we go to the matrix category, they're color coded. When you don't want a piece, you just drag it down here, it's gone. I want this matrix one here. So I bring that up, I snap it on the Unstart program, click on that little animation grid, it opens up your chance to make a new animation. These are pre-built ones. The numbers represent the number of frames. So if you remember your little flip book when you were younger, you had a bunch of pieces of paper and on each page was a little picture, and each picture changed slightly so that when you flipped through it fast, it looked like it was moving. That's what these animations are. Several frames, each one slightly different to look like the image is moving. So we click the plus button to create a new one, and we could draw, we could have some grass here, we could have some sky here, and we could have a tree here. So there's our first frame. Actually, I want a darker color than that orange. So I'm going to click on this color dropper, and I'm going to go here in the orange thing. I'm going to darken that a little bit and maybe get hopefully a kind of a brownish color. All right, so I've got a tree with a brown trunk there. I can make my leaves darker. We're not going to spend all day with that, but I want to copy this frame. So I'm going to copy. If it were one object that I wanted to move and shift around, I could shift it with this icon, but I'm going to use this to duplicate it. Now I'm on frame 2. If I click the arrows, there's frame 1 of 2, frame 2 of 2. They're identical, but on the second one, I want to have a yellow leaf start up here. And I want to copy that to frame 3. And now I want to move my yellow leaf here. I'm going to erase it from there. Then I'm going to copy that one. And I'm going to have my yellow leaf go there and delete it from there. Copy. And on this one, keep moving that down. One more. Keep moving that down. And one more. Bring it down on the ground. So if I start here, there's my frame 1 of 7, and then 2, 3, 4, 5, 6, 7, and that's my animation. You might reverse that depending on what your animation is, but I don't want my leaf to go back up in the air. If it was a mouth that was opening and closing, you could reverse it. If it was a hand waving back and forth. So I'm going to check that box there. So there's my tree animation. I can have it loop or play once. And when I start my program, that it would show that picture on my bolt, and it would show that leaf just repeatedly falling. Sometimes the animation is too fast, so you want to slow it down so we can edit it, close it. We have this control panel here, and we can just slow it down to something that looks good. And you can tell if you don't like it, just go adjust it again. Looks like it will jump. So endless possibilities with the matrix animation. When the bolt rolls to a specific location, you've got something maybe on the floor that is something they were learning in class, a printout of something they were learning in class, or some object that represents that. Then when it gets to that location, it displays an item on the LED that demonstrates their understanding of that object, or a relevant image to go with it. Then it travels to the next location, and it can change. You can have a new image on there. It doesn't have to be an animation. It could just change to a static image. And each location will project a different image there. You also have sensors in the bolt. You have other types of what they call communications on here. The one bolt can broadcast a message to another bolt, so that one bolt rolls up to a second bolt. It will broadcast a signal, and this bolt says, when I receive this signal, then do something. So it might be this bolt rolls up and it sends the broadcast out, and this bolt, the second bolt, receives that broadcast and then displays a certain image on, or rolls away to go off on a new mission. So I've had students come up and they had two bolts kind of fall in love. They rolled up to each other, and each one showed a heart, and then one of them showed an engagement ring, and the other one showed yes on the screen, and they both had hearts again, and they lived happily ever after. It was quite a romantic moment there. For movement with these, it's a little different from any robot they may have seen before, because the movement has 3 parameters. It has a heading, a speed, and a time. So a lot of times with a robot, if you wanted to go in a square, you would say move forward, turn 90 degrees, move forward, turn 90 degrees, move forward, and it would make a square. But in this case, the heading is a little bit of a different concept. And it's not turn right or turn left. It's orient yourself in a specific compass heading. So in doing that, in order to do that, you have to orient your bolt. One of the first things that you do, and I don't think it's going to let me because we haven't paired with a bolt, is when you click on aim up here, or this middle icon, which changes the color, it will give you a circle. And on the perimeter of the circle, there'll be a little dot. And when you grab that dot and move it around the perimeter of the circle, you'll see your bolt on the floor. All of its lights will go out except for one blue light. And as you drag that dot around the perimeter of the circle, it will move the blue light around on the bolt. The bolt will spin, and that blue light will spin with it. That blue light is your tail light. So if you say, I want away from me, when I'm looking forward, I want that to be 0 degrees. So when I tell my bolt to move at a heading of 0 degrees, I want it to be in that direction, towards the front of the classroom. So I would orient that, drag that little ball so that the blue light is facing to me, because that's the tail light. That means the front of the bolt is facing now at the 0-degree heading. Tail light is you put that behind and 180 degrees opposite from the direction you want to be your 0 heading. Once you set that anytime you plop the bolt down on the floor. If you don't, these directions mean nothing to it. So you have to set that first. So we set the heading. I'm going to trash that. And if we started this, these were my code blocks to have it travel in a rectangular path. So if I had it roll 0 degrees at a speed of 50, 50 what? Who knows? That's something the kids can figure out. It's not centimeters per second. It's an arbitrary number that has meaning only to the bolt. So I found that really low numbers, that the bolt barely moves. You don't get any satisfying movement in the times that you set. But you also don't want to max it out at 255. Kids love to do what's the highest it can go. Okay, top speed all the time. And you find that you lose a lot of maneuverability when you have the top speed all the time. You can't turn a corner sharply. You can't make a 90-degree turn going top speed. So, and in the classroom, you don't have the space to go top speed for very long. So I say keep the speeds like under 90, so they're reasonable. If you get in a gym, that's a different story. But within the classroom, you want to keep the speeds down. And then they realize you can't tell this to travel across the room for 10 seconds. 10 seconds and you'll be out the door and down the hall, depending on the speed. So if we go at a heading of 0, so for me, that was straight ahead at a speed of 50 for 1 second, and then change the heading to 90 degrees, same speed, same time. Then we change the heading to 180 degrees, same speed, same time. And then 270. That should make it go in a square path. And the kids can figure that out. Challenge them to have it go in a square path. Challenge them to make a triangular path or hexagonal path, octagonal path. And then with the more advanced classes, they can figure that out. They could, like I said, for the more advanced classes, have them calculate the speed. Have it go measure out the distance that it travels, time it to go that distance, and say, okay, that speed was so many centimeters per second. I had programmed a speed of 60. So if 60 correlates to this number of centimeters per second, then what's the direct ratio here? What is 1 unit on here in centimeters per second? It's a lot of, there's math there for them. There's ratios. There's a lot of problem solving for them. So you can see again, categories across the bottom. You could get as advanced as you want to, but you can keep it as simple as moving and changing the lights here. They can control the main LED. They can have it fade from one color to another. That might be relevant depending on their lesson as well, especially if they were doing something in art class. If you do choose JavaScript, one of the resources I give you in this slide deck is this JavaScript wiki. You got your categories across the top again, and down below it says, okay, you want to move forward, you want to roll. Here's the block that you are familiar with, but under that is the JavaScript code. So it tells you exactly what you need to do. It says we use this await roll, and in the parentheses, we've got the heading, the speed, and the time. So that's as simple as that. When the kids type that in and they see it move, it's such a huge first step in going from blocks to text coding, and it's a very simple step. You don't have to know anything about it. They direct them here, and you can learn it along with them. There's only a few codes they would need to use here. They've got a code for rolling down here in the category for the matrix. It explains all of that. It explains like how the matrix is numbered. And you can say, well, look, remember your coordinate axis systems, the x-axis and the y-axis in math class? You've got this grid here now, and it's similar, except that the first one, instead of 1, 1, because it's 0, 0. Normally that would be kind of down in the corner. You wouldn't use that. So there's similarities and there's differences here. And they can learn how to plot individual points on the matrix, or whole lines, or fill it all in with colors using text code. Very exciting. I will note that this wiki is a Google site, and some schools block Google sites because of a gaming exploit. So you can ask that your IT department unblock this particular URL to give students access to that. All right, let's finish this up. So I think we've covered everything on here. We talked about cleanup, and you can use like disposable wipes, Clorox wipes, to wipe off the silicone shell if they get dirty and hairy. Same thing for the pads for the Indy cars. Here are the resources. These include the videos that I showed you, the full videos, introductions to the Bolt and the Indy, the JavaScript wiki. These three videos down here, longer videos, but if you've got some students that are really ready to go above and beyond, and you want to know yourself, it explains all of the extra features, all of how to work with sensing, how to work with variables, and all of the advanced coding things you could do. But you don't have to. Don't let that intimidate you. You have applications here. If you just stick with moving these robots around on your floor, you're going to be able to incorporate them in anything you do. And I would remind you, there's going to be problem solving with these. Kids are going to learn things. You're going to learn things. There's value in that. Make sure that as you're applying these to your curriculum, that you're not just bringing these in to use them for the sake of using tech. We want to make sure that we're doing it in a meaningful way. Are they really enhancing your content? And I think it's really easy to find ways that they are. And if you would ever like to chat about any of this, you can definitely contact me, Chris Beckwith, and I will be happy to meet with you video chat, or if you're nearby, I can visit your school. We can talk about some ideas on how to incorporate these into your curriculum. But we are always looking forward to hearing from you and improving what we do. Thank you for joining us. And if you scan that code, use that link, we have a feedback form. You can tell us what you thought of this presentation. Now, on behalf of the whole MLTI team and the Learning Through Technology team, we're all available to deliver professional development like this to your schools upon request. Thank you again for joining us for this video, just some of the services that we offer upon request. And feel free to use this presentation in anything in your content if you want to share it with other people. And moment you've really been waiting for, your contact hours for sitting through this video if you participated in the prep workshops or any other professional development that offered credits for this. You get an hour of credit for sitting through, whether it was the level 1 or the level 2. I kind of wrapped them both into one session here for the sake of time. So this will get you the form for your contact hours. Thank you again, and I look forward to hearing some of the exciting things you do with these robots.